Hi everyone, welcome to my channel, Tortellini Test Prep. Today we will be going over Ottocento number 19, Quadratic Formula. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, this is the most important slide on the whole thing, the quadratic formula. So whenever you have a quadratic equation in standard form, ax squared plus bx plus c is equal to 0, the quadratic formula tells us that the solutions are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Definitely pause the video, take a second to write this down, because this is not on the reference sheet. Just some general advice. So you always want to try to factor first. Do not use this if the quadratic is factorable. Try to factor first, or even use Desmos if you don't know how to factor it. It still might come out nicely. And second, a good clue that you need to use the quadratic formula in an SAT question is you'll see like a square root symbol kind of in the problem. More on that later. So be on the lookout for square roots in the question. And make sure when you substitute into the quadratic formula, you use lots of parentheses. 90% of mistakes come from evaluating incorrectly by not putting enough parentheses. So you'll see that when we do the examples. So first of all, this is kind of, I don't know, this video is really important for a video I'm going to make later. So I did it anyway. However, if you have a physical calculator that can solve quadratic formula questions, please just use it. It'll save you a lot of time and stress. I actually have two videos going over this. One for the Casio FX991EX, which has been discontinued, and one for the TI-30X Pro Math Print, which is my personal favorite, which is what I use to do the practice tests and make my videos. So you may notice the TI-30X Pro Math Print, it only ships out of Europe. So you have to get it off eBay, and it can get pretty expensive, even though it only costs like, in the store, it costs like $15 or $20, maybe $30. But you see here, it costs like $60, which is like kind of a lot, and it takes a really long time to ship overseas. So if you're comfortable compromising a little bit, if you're used to TI, if you live in America or you're in an international school that uses TI calculators, you're really used to TI, but you can't get your hands on that previous one, I would get the TI-36X Pro. So the TI-36X Pro cannot give you exact solutions to quadratic formula. However, it can simplify radicals, which is helpful for what we're going to do later in the video. And it can do other things like unit circle trig, etc., blah, blah, blah. So this is a really good option if you like Texas Instruments. And again, it's like $20, especially if you live in America. Now, if you don't live in America, or for whatever reason you're super comfortable with Casio, and maybe you've never used either of them, so you don't have a preference, I would definitely go with this one. So this is a still in production. It's kind of like a baby version of the Casio I was talking about at the beginning. So it's called the Casio FX115 ES Plus Second Edition. As you can see, it costs like $17, so that is like a steal. And it can do quadratic formula, and it can do all those things I mentioned. It can do quadratic formula. It can simplify radicals, unit circle trig, you name it. So this is a great option if you have no preference. Again, just don't change brands if your test is coming up soon. That's not really worth it. That'll probably just confuse you more than help. But like I said, if you like Casio or you have no preference, this is a good option. One more thing. Kind of keep in mind that I don't have a video for this exact calculator. My video is on the Casio FX991EX. However, the inputs are incredibly similar, so you should be able to figure it out if you go watch that. Okay, so here are the steps for the quadratic formula. First, we're going to identify A, B, and C. Then we're going to plug in or substitute those values for A, B, and C. Next, we're going to clean up. In other words, evaluate the three pieces. Then we're going to simplify the radical if possible. You can't, not all radicals are simplifiable, but simplify the radical if you can. And then if it kind of makes sense to, you should also split the fraction. We'll talk about that when we do a problem. Okay, so here's a question. You'll kind of notice if I take a cursory glance at the question, I see lots of plus or minuses and square roots, so this is kind of telling me it's probably not factorable and I should probably use the quadratic formula. Now, the first thing I notice is it's not in standard form. So the 6 is on the wrong side of the equation. So to get it in standard form, we're going to subtract 6 from both sides. And we get x squared minus 7x minus 6 equals 0. We're now ready to identify a, b, and c. A is 1, b is negative 7, and c is negative 6. Now we're going to pull out the quadratic formula, and we're going to put all those constants into the equation, and just make sure everywhere I put a color, you put that number, and then you also put parentheses. So it should look something like this: negative negative 7 plus or minus root negative 7 squared minus 4, 1, negative 6 over 2 times 1. Don't do any of that math in your head. Write it down first. Like I said, this is where 90% of the mistakes happen, is people, they go to try to do it in their head and they mess up, right? Now at this point, we're going to clean up these 3 pieces. You see, like this, this, and this. And if you're unsure how to evaluate what's under the square root, you can just jump to your calculator. Don't be embarrassed, right? It's confusing, right? So you could just type negative 7 squared minus 4, 1, negative 6. Just quickly jump to the calculator and figure out what that is. Anyway, negative negative 7 is 7. 2 times 1 is 2. And then that big mess, the radicand, is 73. Now, root 73 is not simplifiable, so we don't have to do that. And we could split this fraction, but it doesn't really make much sense to do that because 2 doesn't go into 7 and 2 doesn't go into root 73. So I'm just going to leave it like this. Just know that we could split it up if we wanted to, but remember, if you saw the answer choices, we probably don't need to do that for this one. Okay, so let's come back over here, and it's looking like that is answer choice C. Now, kind of a moot point for this one, because you could just check the answer. You could just guess and check using Desmos like I did here. So I didn't type in the other answer choices, but if you typed in all the other answer choices, you will see that they don't match what's on the graph. However, just now we're going to do harder ones. As always, we're going to do harder ones where perhaps it would be harder to use Desmos, and knowing how to do this will be a lot more helpful. Don't listen to him, SpongeBob. Remember, ravioli, ravioli, give me the formuoli. Okay, skill number 2. So pay very close attention to this question because this is probably how quadratic formula shows up like 95% of the time on the test. I suppose sometimes they could do this question as a multiple choice, but they don't have to, as you'll see. So definitely make sure you pay attention to this one. Okay, so we're going to do all the steps we did before. First of all, I'm noticing this square root in the question. You see where it says a minus square root b. So that's kind of telling me that I should be doing the quadratic formula. So we're going to identify a, b, and c. A is 1, b is negative 10, and c is 8. We're going to take out the quadratic formula, and then we're going to plug in. So I get negative negative 10 plus or minus negative 10 squared minus 4 times 1 times 8 over 2 times 1, making sure to use lots and lots and lots of parentheses anytime I replace a letter with a number. And now we're going to clean up the 3 pieces. So negative negative 10 is 10, 2 times 1 is 2, and then this radicand, negative 10 squared, blah, 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 is 68. Now, square root of 68 is simplifiable, so we're going to go over how to do that on the next slide. If you had a scientific calculator, we could make very short work of this. You just type in square root 68. But let's go over how to do it by hand for the people who don't have it. Don't have one. So, square root of 68. The numbers you're looking up at the top are all the perfect squares from 2 squared to 12 squared. You should know all the perfect squares from 1 squared to 12 squared by heart. Now, 1 squared is just 1, and you're going to see when we simplify radicals, we don't really care about pulling out a 1 because it doesn't really help us. So we really only care about the ones from 4 to 144 when we're doing this. Anyway, so we're going to ask ourselves, what's the largest perfect square that goes evenly into 68? Well, in order for it to go in evenly, it certainly must be smaller than 68. So let's look at all the numbers smaller than 68. And then you could kind of just rattle down the line, and see for yourself which one goes in evenly if you're not sure. Spoilers, the biggest perfect square that goes in evenly is 4. So we're going to do square root of 4 times whatever's left over, which is 17. 4 times 17 is 68. And we're going to pull out the largest perfect square. So the square root of 4 is 2. So this guy's simplified would be 2 root 17. Now, if you weren't able to see that, 68 is kind of a big number, and these numbers are kind of wacky, so it's kind of hard to see. You could whip out Desmos, and you could just start guessing and checking down the line. You see how I'm doing 68 divided by 64, 68 divided by 49, 68 divided by 36. This is incredibly inefficient and brute force, but if you're struggling with number sense, this is a good thing to fall back on. Notice how all those first numbers, they have decimals. That means they don't go in evenly. But when I do 68 divided by 4, I get 17 with no decimal, no remainder. That means it goes in evenly. So as soon as you get to the largest possible number that does that, you would stop. We just went all the way down the line because coincidentally, 4 was the largest number that goes in. Anyway, so we're going to take this and we're going to replace the root 68 with 2 root 17. Now I'm thinking, we should probably split this fraction because there's a lot of even numbers going on here, right? So you can draw a little like heart. So we're going to do 10 over 2. So 10 over 2 is 5. And then we're going to do 2 root 17 over 2. That is just root 17. So we're going to do x equals 5 plus or minus root 17. Again, 10 over 2 plus or minus 2 root 17 over 2. But as we said, 10 over 2 is 5. 2 root 17 over 2 is root 17. And now I'm going to go one step further. I'm going to break it up into the 2 solutions. So we've got 5 plus root 17, and we've got 5 minus root 17. Now we're ready to go tackle the question, so let's go do that on the next slide. Okay, so you see how it says a minus root b? It doesn't really matter that much, but you guys kind of see they're talking about the solution on the right. See how that more closely resembles what's in the question? Again, it doesn't matter which one you pick, you still get the same answer, but I don't know, I'm just trying to be consistent so that you guys can follow. Okay, so A is 5 and B is 17. So that means A times B is 5 times 17, which is 85, and that is the answer. So sometimes they do make these multiple choice, but sometimes they don't. And especially when they're not multiple choice, you really can't guess and check. So you should make sure you know how to do the quadratic formula if you don't have a calculator that can do it already. I'm very fortunate. I could have just typed this problem into my scientific calculator and gotten the answer. So as you kind of see, if I typed in all the coefficients, the first solution, x1, would have been 5 plus root 17. The second one's 5 minus root 17. And then I can just quickly answer the follow-up question. And we can also check our work on Desmos. I more do this just to prove to myself that it's right, so I hopefully didn't make a mistake, right? But if I make a equals 5, b equals 17, and then I type in a plus root b and a minus root b, you see we get the 2 solutions that are on the graph. So that's a good sign that we did a good job. Okay, lastly, this is where having a calculator that can do this maybe really isn't that helpful because this is a more conceptual question. And these only come up once in a super blue moon. I've only seen it like once or twice, but you never know. So I really wanted to include it just for the sake of being thorough. So we look at this equation and we're going to try to do the quadratic formula on it, even though they don't give us a whole lot to go off of. So A is 1. B is just B. I know that's confusing. There's a textbook B and then there's a B in the problem. Well, the B, air quotes, is just B. And then C is just C. So we're going to do the quadratic formula, put all the colors on there. And you see B and C are just a different B and C, so we don't really change how that's written. But the A's we're going to replace with 1s. And 2 times 1 is 2. And -4 times 1 times c is minus 4c. So those are our two solutions, -b plus or minus root b squared minus 4c all over 2. Now, if we look at the stuff they gave us, do you guys kind of see now, oh, wait a minute, these kind of look like the quadratic formula, but there is no 2 there, right? So what we're going to do to each of these equations to get the 2 there is we're going to divide both sides by 2. So if we do that, we get -b plus root b squared minus 4c over 2. That's one of the solutions based on what we came up with, is equal to 4. And then -b minus root b squared minus 4c over 2 is equal to -7. And that's also one of the solutions based on what we come up with. So x must equal 4 or x must equal -7. Very confusing question, but if you actually kind of write it all out and you see, oh, wait a minute, Kyle, that does make sense. The 2 isn't there. Why don't we do some algebra to put a 2 there? So that's what we did. Anyway, so those are our two answers. It says, what is one possible value of x? So you could put either one. Okay, I think that's it. It's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comments section. Let's jump to the whiteboard for the final review. Okay, question 1. So fortunately, this equation is already in standard form. So I see that a is 1, b is 9, and c is -5. Now we're going to put it into the quadratic formula. So, and I'm going to use lots of parentheses. Don't do any math in your head. -9 plus or minus the square root of 9 squared minus 4 times 1 times -5 over 2 times 1. So -9 is just -9. 2 times 1 is just 2. Let's see the square root of 9 squared. Let's see what's 9 squared minus 4 times 1 times -5. I'll just do that part on a calculator real quick. I'm getting 101. I don't think there's any perfect squares that go into root 101, so it doesn't really into 101, so it doesn't really make sense to simplify this. That is looking like answer choice A. Okay, question 2. So for this one, guys, you'll notice it's not in standard form. I didn't really talk about this in the video too much, but I would highly suggest you try to keep A positive. So even though it might be faster to move the 3x squared to the right side, that would make A negative. So let's move those terms on the right over to the left side. So that will look like 3x squared, subtract 12x from both sides, so -12x, add 7 to both sides, plus 7 equals 0. It's going to look something like that. Like I said, just try to keep the A positive. That's probably a good habit to get into. Just makes it easier. All right, so we can now see that A is 3, B is -12, and C is 7. And we're going to put that very carefully into the quadratic formula. So -12 plus or minus the square root of -12 squared minus 4 times 3 times 7 over 2 times 3. And that gives us, we get 12 plus or minus the 2 times 3 is 6, and then the square root, I'm going to use a calculator for this really quick. -12 squared minus 4 times 3 times 7. That is giving me 60. The square root of 60 can be simplified. The largest perfect square that goes into it is, I believe, 4. Yeah, so it becomes square root of 4 times 15. And if you pull out the square root of 4, that's 2. So it's 2 root 15. So what we're going to do is we're going to kind of rewrite this, but with instead of a root 60, we're going to do 2 root 15. And you kind of see, guys, that's not really resembling any of the answer choices. However, this can be simplified. We could split the fraction if you want, but notice how all of these are divisible by 2. So if we divide everything by 2, we get 6 plus or minus root 15. 6 divided by 2 is 3. And we could split that up, but there's not really much reason to. Look at the answer choices. That is looking a lot like answer choice D. Okay, question 3. Once again, this one's already in standard form, so we're kind of in business. So A is 1, B is 6, and C is 2. So we're going to do negative 6 plus or minus the square root 6 squared minus 4 times 1 times 2 over 2 times 1. And if we evaluate those kind of three pieces, negative 6 plus or minus on the bottom is 2. And then 6 squared minus 4 times 1 times 2, that is 28. Root 28 can be simplified, so let's do that over here. So the largest perfect square that goes into it is, I believe, 4. So you could rewrite root 28 as root 4 times 7. And that gives you, if you pull out the 4, you get 2 root 7. Okay, now we're going to simplify, and more specifically, the bottom goes in evenly to both of them. So we're going to like split this fraction using like the heart that we talked about, something like that. So negative 6 over 2 plus or minus 2 root 7 over 2. In other words, negative 3 plus or minus 2 root 7 over 2 is just root 7. So the two solutions are negative 3 plus root 7 and negative 3 minus root 7. And you'll see more specifically up here, it doesn't really matter, but it's talking about that one. So the one with the plus in the middle, so A plus root B. So that means that A is negative 3 and B is 7. So we're going to do A minus B. That's what the question wants. And we're going to do negative 3 minus 7. And that gives us a final answer of negative 10. Okay, question 4. So once again, we're actually in standard form. So that's good. So A is 1, B is negative 18, and C is 71. Okay, so we got negative 18 plus or minus the square root negative 18 squared minus 4 times 1 times 71 all over 2 times 1. So negative 18, that's just 18. And 2 times 1, that's just 2. Now I'm going to use a calculator for this part because those numbers are pretty big. Negative 18 squared minus 4 times 1 times 71. Okay, I did all that in a calculator and I got 40. All right, once again, it seems like the largest perfect square that goes into this one is just coincidentally 4. So we're going to rewrite this. Square root of 40 is 4 times 10. So we're going to put up here x equals 18 plus or minus. If you pull out the 4, it becomes square root of 4 is 2. So 2 root 10. And we're going to once again split this fraction by making a heart. 18 over 2. And then 2 root 10 over 2. and we get 9 plus or minus root 10. So the two solutions are 9 plus root 10 and 9 minus root 10. And it doesn't really matter, but you'll notice in the question it says a minus root b, so it's talking about the one with the minus sign in the middle. And you will see that a is 9 and b is 10. So we're going to do a times b. So a times b is equal to 9 times 10, which gives us a final answer of 90. Okay, question 5. This one's not in standard form, so I'm going to just quickly move that negative x squared to the other side. So let's add x squared to both sides. We get x squared plus 4x minus 44 equals 0. Something like that. And so a is 1, b is 4, and c is negative 44. We're going to put that all in, so negative 4 plus or minus the square root 4 squared minus 4 times 1 times negative 44 all over 2 times 1. So this gives us negative 4 plus or minus the square root of, and this is, and on 2 times 1, that's just 2. And let's see, what is all that business on the bottom? So 4 squared minus 4, 1, negative 44. It's 192. And this one's kind of tough to see, guys, but even if you don't see it, you could just, and you don't have a scientific calculator that simplifies radicals, you could just guess and check going down the perfect squares. So the largest perfect square that goes into it is 64. So we can rewrite this as 64 times 3. And then if we pull out the 64, square root of 64 is 8. So this becomes 8 root 3 over 2 times over 2. And now we're going to once again make the little heart, split the fraction up. So we get x equals negative 4 over 2, that's negative 2, plus or minus 8 root 3 over 2, that's 4 root 3. And so that means the two solutions are negative 2 plus 4 root 3 in simplest radical form, and negative 2 minus 4 root 3 in simplest radical form. And you'll notice the question's talking about this one, a plus b root c. It's got a plus in the middle. Again, doesn't really matter. So a is minus 2, b is 4, and c is 3. So we want to find a plus b plus c, so that's negative 2 plus 4 plus 3. And that gives us plus 3. Let me fix that. And that gives us a final answer of 5. Okay, question 6. This one is in standard form, so we're in business. So a is 1, b is minus 22, and c is 103. So x equals negative 22 plus or minus the square root of negative 22 squared minus 4 times 1 times c is 103. 103 over 2 times 1. So let's see, negative 22, that's just 22. Then we're going to do plus or minus 2 times 1 is 2. What is negative 22 squared minus 4 times 1 times 103? That is 72. And we can simplify root 72. So let's see, the largest perfect square that goes into it, I think, is 36. So we can rewrite 72 as 36 times 2. And then when you pull out that 36, the square root of 36 is 6. So this would be 6 root 2 over 2. Everything's divisible by that denominator, so we're going to once again split the fraction using the little like heart method. So we get 22 over 2, which is 11, plus or minus 6 root 2 over 2, which is 3 root 2. And we're going to write the two solutions out, so 11 plus 3 root 2 and 11 minus 3 root 2. And it's not going to affect the answer, guys, but you see they're asking about a minus b root c, so that's this one. So that means a is 11. You know, the minus sign's already there, so I don't really need to worry about that. 3, b is 3, and c is 2. And we want to find a times b times c, so a times b times c is going to be 11 times 3 times 2. And that should give us a final answer of 66. Okay, question 7. So we're in standard form, so a is just 1, b is just b, and c is just c. That is a little confusing, but basically the b and c aren't going to get changed at all because it's just b and c. It's just the same letter. It's talking about something different, but it's going to look the same. Minus 4. A is 1, c over 2 times 1. So the solutions are negative b plus or minus negative 4 times 1 times c is just minus 4c. And 2 times 1 is 2. So we're now going to use this to figure out the answer based on what they gave us. So you see both these equations, they're just kind of missing the divided by 2 part. Looks the same besides that. So to get the values of x, you only need to find one, but I'm going to do both of them for the video. We're just going to divide both sides by 2 so that they look like that. So see, oh wait, now if we did that, those equations would look like our x values that we got from the quadratic formula. So the first one is 36 over 2, which is 18. And the second one is negative 4 over 2, which is negative 2. Either of those would have been acceptable answers. Okay, question 8. Once again, this one's in standard form, so a is 3, b is just b, and c is just c. So the b's and c's, they're not really going to change. Those are going to be the same letter, but a is 3, so we got to put that in there. Over 2 times 3. And when we clean this up a little bit, we get negative b plus or minus the square root of b squared minus 4 times 3 is 12, so 12c over 6. And now you'll notice, wait a second, that looks very similar to the two equations. It's just missing the divided by 6. So we're going to go back up to both of those and divide each side by 6. And so the first one is 2 over 6, which simplifies, you just use a calculator, is 1/3. And the second one is negative 102 over 6, which is negative 17. And then the question just asks for the positive difference between the two possible values of x. Remember, quadratics can only have up to 2 solutions, so there is no third solution or anything like that. So to find the positive difference, you can subtract them and take the absolute value, or you can just do the bigger one minus the smaller one. So 1/3 is bigger. So we're going to do 1/3 minus the other number, negative 17. And I do that on a calculator. You can use Desmos if you want. And I am getting 52 over 3, which is our final answer. Okay, everybody, thank you so much for watching until the end of my video. Please comment below your thoughts on the video and worksheet. Did you find them helpful? Be sure to like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.